Thank you for the cool introduction. Hello, my name is Michael Telloyan. First, like a few minutes ago, I asked you, and like you are the only English speaker according to the audience.
That's fine.
But I mean, I'll keep English for the like core structure, but sometimes like mix in Japanese is along. BIN2TL takes a very simple approach to visualize the binary. First it'll capture everything for like binary execution and like converts it into a like interactive profile like this. In the next 40 minutes, I'm going to explain previous challenges, what the current like previous workflow had in problem, and then I'll propose the concept and implementation. And hopefully, if I have time, I'll be able to show you the demo and actually run the demo. By the end of time, you'll be able to probably understand what this workflow is and how it can transform your everyday binary analysis. So this is me. My name is. I do like both engineering and reverse engineering. I have some like CDF background. I went to like DevCon CDFs and other like on-site CDFs. I'm currently working on a project at Mandiant called Xrefer to abstract Ibra and IDA and like Binary Ninja into a like Pythonic framework, so we can just interchangeably like switch backends and like better profit. But that's another story. Today I'm going to talk about it. So binary analysis takes time. Like it's like by nature, and like our goal will be to minimize the time. So we want to create a timeline. So what if we can just like see how the binary actually executes and like figure out what the arguments are and like what like how the thread actually works. And that way you don't need to like open up GDB and open up IDA and like switch between and like run GDB again and like that takes time. で、まあ日本語でちょっと戻すと日本語で言うの忘れてた。まあなんか、まあ CTF のバックグラウンドがあるんですけど、まあなんかリバースエンジニアリングとかエンジニアリングをやってて、で、まあ所属はリシュテルカセキュリティのなんかジュニアセキュリティエンジニアみたいな感じなんですけど、現在まあマンディアと X レファーというプロジェクトでまあ間とバイナリ忍者とギドラをなんか抽象化してなんかPython らしく扱えるようなレイヤーを開発するってことをやってました。で、解析時間が長いのが問題でした。つまりまあなんか間で開いて理解してでデバッガーに切り替えてでもう一回デバッガーを発射させてみたいな。で、まあこの時間をなるべく短縮したいっていうのが目的で、そのためにプログラムをすべて動作を取得してでその後綺麗なタイムラインに移すことで1回のまあ実行だけでまあその何回もインタラクティブにフローを得るようなものを作りました。で、so for those who don't understand binary analysis or don't have a background in binary analysis, so maybe you'll start. I'll divide binary analysis up into like 3 parts. Maybe you'll start with surface analysis like files, strings, binlog. Maybe you check the headers, and once you're satisfied, or if you want to move on, you might open up an IDA or Ghidra. This will actually show you. This will try to show you the logic, like instruction level or intermediate language level or pseudocode level. But these can be wrong. It's not really a readable format. And this takes time. And obviously, static analysis like doesn't work against like obfuscation. If it's obfuscated, you can't like naively just static analysis. You might not, you might want to do dynamic analysis or write a custom pass to like the others they did. So like for if you're like if you want to get like dynamic context, you might go move on to dynamic analysis like debuggers like GDB, and these are like you can really like move like C register value, and you can like customize it, but it's generally like program specific. Like you have a specific address, you like breakpoint it and like you stop it and like observe and just continue. Like it's not like a program you can run for every binary. And if it's multi-threaded, like it's not really a good experience. And like debuggers are often like platform specific. Like GDB won't work on Windows, and vice versa. So we want a better like binary analysis experience. And oftentimes the problems, like common like questions you want to ask is just like what's timing, like what function runs after what, like, and like what are the actual arguments being passed. Maybe it's like value or something. That like how many times it's like running, like maybe there is this not concrete value, and you might want to know like what the actual value is, and like how long it takes. Like you can't really guess how long this function takes from just static information. So we want to just solve everything of that and like with small overhead, because large overhead means like that's really not minimizing the analysis time. And so here's the demo. So it's a very simple like baseline program. Like it's just to showcase what the BIN2TL output might look like. So you have func A, func B. Func B looks like this. So if you pass this into BIN2TL, you get an output like this. And if you zoom in here, you get, so this is what the format looks like. And if you click on this like trait, you get like these values. So it shows what the arguments were and like the return value. And if you check the logic here, it is actually correct. So we can, and if you write SQL query that Perfetto supports, you can like observe how the arguments were passed and like what the return values were for like timeline and like chronicle order, and also shows duration. This is what Perfetto does. It is not implemented by BIN2TL. We are just free writing on the ecosystem. But I think this is a pretty cool way to analyze the binary. And so my proposal included ransomware, but I forgot to say it already, sorry. そう、これ、まあいいじゃん。まあ、デザインとして、なんか、BIN2TL の、まあ、どういうふうに動くかっていうのを証言するために、まあ、なんかこういう単純なプログラムを書いてる。で、これが BIN2TL の中でどうやって表示されるかというと、まあ、このような、まあシステム全体をトレースしているので、描くはないんですけど、まあ、注目するべきところはここで、で、まあ、こういうふうにクリックすると、関数の引数と、なんか開始が動されたり、まあ、なんか関数名、例えば、まあ、バイナリーメインの中からファンク A が呼ばれて、その中で、まあ、なんかこの関数と、この関数とこの関数が呼ばれてる。で、まあ、なんかこの後、まあ、結構呼ばれてるな、みたいなことが分かるわけです。で、まあ、こういうのって、まあ、こういうのです。で、これだと、関数の引数と、モード1 が、テーブル上に表示されてます。で、時系列で相当されてます。これ自体はパーフェクト自体の、機能で別に BIN2TL 自体が、実装したものではないんですけど、その、あえて既存のビジュアライザーを流用するという、デザインによってこういうことが、まあ、再発明しなくてもできるようになっています。で、まあ、so the next example is ransomware because I included in the proposal, but like I recall that this is Japan and I don't want to get caught, and like I had to be very careful with the wording. So I'll just replace it with a threading. It'll just showcase good enough like how this will handle threaded applications. So this is a like very basic threading example. And so if you run this, like you can observe that we actually capture the threaded applications. Do I have this right now? Oh no, never mind. So this is the trace. Hopefully, if we have time, we can. I hope I can like actually run this and like showcase what the like actual overhead looks like and how the experience feels. So for technical details, so this is what Entopin looks like. This is not the implementation, but so basically, so there is concept for analysis time and instrumentation time, and so you'll register a callback function to like instrument. So like for every instruction, insert a call to this function, and Ducon will get a call every time for every instruction, and this will print out like how many instructions were called. So PIN has many functions like insert instruction. Like you can insert a callback function for like instruction level or a basic block level or image level. So that or like yes, and like you can also instrument like every memory read or memory write. So if you want to just observe like what strings are actually read or like what signals are emitted, you can do that. That is not the like scope this BIN2TL itself, but there are tools like that, and it is a very powerful tool to create your own like binary analysis tool with great customizability. で、なんかそもそもピンがどういうものかっていうと、まあインテル社によって開発されてて、現在もまだメンテされているバイナリを計算するツールです。バイナリ計算って何かというと、バイナリをまあ改変することで、例えばインテルのピンだと、例えばインストラクションだったり、ベーシックブロックだったり、まあ、リュードで、まあ、その改変することができて、で、例えば、メモリーリードが起こった時だったり、メモリーライトが起こった時に、こういう関数を読んで記録してねみたいなことができるので、まあ、それを作ると、例えば、自動でアンパックしてくれるトレーサーを作ったり、メモリーに流れてる情報をすべてダンプするツールを作ったり、まあ、このようにプロファイルして、すべてのなんかコールとリターンを記録するみたいなことができます。で、so why did I choose PIN? Like there are other DBI tools like FRIDA or what was it? Like QDBI or DynamoReal. For PIN, like it gave me great customizability, like and the ecosystem, like it is still actively maintained by Intel, which is surprising. Like it's probably like 20 years old, and not sure like who's using it, but I'm glad that they're still supporting it, and it has a accessible range of overhead, so I just stick to pin. And for FIDA, it doesn't like give me the granular like instruction level or like memory like level like callback. So it feels like a different thing. And so our question is, why don't you just build your own visualizer? So we, as we've seen, we use like Perfetto or like Chromium trace format, Chrome's trace format. But and we can just natively build it, but then we have to maintain it. And like I don't want to maintain my own visualizer, while like there's this bigger ecosystem that like is directly integrated into Chrome and Android's development cycle. And probably Google will just maintain that for themselves. So I just decided that if I just use it, Google will probably maintain it for probably next 5 years at least. And this is Perfetto. Forgot to do this. So it is a trace for like visualizer used by Google. Is this it? And like same for tracing format, and this is the one that's actually integrated into Chrome. And like if you just open up DevTools, you can see this view. And so let's just see how this works. Hopefully it works. So I uploaded the binary right now, and it executed and traced it. And it uploads to a website called trace.cafe, which is an awesome website maintained, still actively maintained. So we uploaded, this is a standard output that the program emitted. This is being traced. So the system just will upload take the like artifact and displays it in the like lower column here. And so if you just want to like interact with it, so I have bad eyes. So this is the binary main, and like on that there's this AS encrypt and like AS related functions. We can see the function going. Okay, so we are like calling encrypt and decrypt in this order. So I think you can technically understand this from like IDA, but this gives you a very high level overview of how binary executes itself, and like the order of it. And my subtitle actually includes Perfetto, but this is the Perfetto that view was the Chromium DevTools. So it works, right? So yeah, this is this is how you'll probably interact with binary. After you get an overview, you might switch back to IDA and my interact with this website back and forth, but at least you don't need to run the debug session again and again. So there have been previously works related something like this, but I don't think there have been a work exactly like this. So at concept level, we clearly divide the capture time and the analysis time. We want to separate the environment And also we want to like directly support like profile like this instead of just linear like table-like execution flow. I honestly think this is a like way accessible, like easier to understand format than a linear format. And like at a technical level, we can like probably compare to some like trace tools or like debuggers. I have some of these. So we want to support ELF and to also support P. We don't want to like maintain two versions. We want to have the same like source code and like both analyze. And oh, forgot. 日本語で話すの忘れてましたね。大丈夫ですかね。なんか、皆さん、さすが。で、so, let me switch my. So, want to like customize it like by our own, and we don't want to like interact with it in a sense that we don't want to like take care of the binary. Like we don't want to like really figure out like what address to look at. And for granularity, like there are some tracers that only support function level or instruction level, or maybe like syscall. We want to all like support everything, and for like built-in visualization, and we want to keep the performance like penalty low. We want to be super aware of this, because the slower it gets, like you can't like it doesn't scale well. So for comparison, we have ltrace, strace, GDB, FRIDA, a trace analysis tool from NSA. I'll explain this later. OpenTelemetry, BPF, profiler, kind of self-explanatory, but and process monitor and training tracer and BIN2TL. So ltrace is just like it's free. It's a library tracer. stracer is a syscall tracer. GDB is a debugger. FIDA is kind of like a debugger for Android. It's technically a DPI tool, but people use it almost like a debugger. And trace analysis, I think this is still actively maintained by NSA. They open source this, but I don't think like no one is actually using this, and like there aren't that documentation yet. This is actually cool, and they support. They also use Intel Pen, but they have like VirtualBox tracer or like human tracer. And OpenTelemetry TBPF profiler. This is, I think, one of the non-reverse engineering context reverse engineering tool. It's developed with a goal of like observability and like tracing, but it uses eBPF to profile the like function level. I think that's my understanding. Process monitor only works on P. They said they support ELF, but I haven't verified it. If any of you use ELF, like process monitor on ELF, please let me know. いないかな。プロセスモニターってなんかエルフでも使えるらしいんですけど。なるほど。まあ、使ったことあるかもしれない。で、まあ、tiny so this is a tiny tracer, but yeah, this is a tiny tracer. Also developed by Pen, and we have BIN2TL. So ltrace only supports ELF, and you don't need to configure it. Else, strace is like saying like in GDB, as we said before, we can customize it, but the performance penalty if we want to do something like this is very bad. FRIDA supports ELF. It might support PA. I forgot. I need to check that. And we can like customizable, but we have to like configure the address and so. So this again doesn't come with visualization. And trace analysis. This supports LFP and customizable, and it's the same like design principle, I think. So it's not interactive, and the granularity is and visualization. I think they're trying to integrate this into Ghidra. That I'm not sure like what the direction they're going with, but as of like right now, I'm not aware of a visualization tool for this trace analysis tool by NSA. For instance, since they support different like tracers like VirtualBox and token or like S3 parser, it very depends. And OpenTelemetry, since they're using eBPF, the performance is very low, and like OpenTelemetry is a good like huge ecosystem, so they support visualization. But this chart is wrong. This checkbox needs to go to ELF. Sorry. And I don't think they currently support P. And process monitor, you can't really customize it, and like it's the like granularity, like it doesn't support binary function at all. It only supports like library calls. So that's not good enough. Retain tracer, it used to only support like the configure functions the functions you pre-configured. So, but maybe I think they updated, so the this might be changed. But it doesn't come with visualization, and BIN2TL supports LP, and like it's highly customizable, and like you don't need to really like pre-configure something in order to like match the binary, and it comes with visualization, and it's performance aware, so it's free. The overhead is pretty low. So to sum up the like talk, we convert binary into a timeline format, and it captures dynamic context, and it supports both ELF files and P files. And thank you for listening.
ここありがとうございました。何か質問等ありますか？ Do you have any questions?
英語の方がいいんですか？どっちも。じゃあ日本語でちょっと失礼するんですけど、これってちなみにマルチコア環境で動いてる並行プログラムとかでも正確なトレースが復元できたりします。
テスト精度だけ、テストしないんですけど、
いける。
しないだと。
そうですね。やっぱそこがどうなのかなっていう、そのマルチコアで動かれたときにこう正確なトレースが取ってこれるかどうかっていうのがなんかちょっと気になったので聞いたんですけど、ありがとうございます。
他に質問いらっしゃいますでしょうか？はい、そしたら
このまま簡単な質問で、今 GitHub でこれ使える
使える状態ではなくて、あくまでこのなんか発表に関する情報を集めている場所で、なんかもうちょっとテストしてなんか正確性とかなんかコードがよりなんか綺麗になったらいつかパブリッシュしたいなと思ってます。
はい、ありがとうございます。